So question type 2, that's so what happens, what goes on in this question is that Kc will already be given to you because that's Kc is already given. And what you have to do is you have to find the equilibrium concentration. Now, how are you going to do that? The way you're going to do that is, okay, let's say I've got a question that says that initially, here's the example question. So initially, we had 0.2 moles of H2 and I2 mixed in a container. And that's mixed in a container with 0.4 moles of so 0.4 moles of HI. And the Kc value is coming out to be 3.1. So the Kc is already given. And you're being now asked why find the concentration of the reactants and products. So find concentration of reactants and products at equilibrium. Yeah, that's the whole question. The way you're going to figure this out is that they'll obviously give you the reaction, which is that H2 and I2, तो सब कुछ वही करना है. It's H2 and I2 and they're reacting together and they're forming they're in equilibrium with so they're in equilibrium with HI. So everything is kind of the same. You've got your initial moles. The initial moles that you have are okay. Initially, the container has is already added the initial things. So initially, the container had 0.2 moles of H2. So and it also has 0.2 moles of I2, and it's got 0.4 moles of HI. Okay, that's already given in the question. What you don't know is how much of the stuff is reacting, whether the equilibrium is moving to the right or whether the equilibrium is moving to the left. You have no idea. They didn't give us any information about the equilibrium moles. So what you're going to do is you're going to just make an assumption. Okay, maybe the reaction moves in the forward direction, right? And maybe X moles of H2 react. So X moles react for H2. Is that clear? Now that's just an assumption. I don't know whether they're they're reacting or are they getting produced, but that's just my assumption. I'm just assuming that X moles react. So if X moles react, so how many moles of I2 will react with it? It's going to be 1:1, right? So that means X moles of I2 will also react. ये clear होना है? Is this clear, Ahmed, Rafe?
जी सर.
Yes, sir.
So that's just an assumption that X moles react. So X moles of I2 must have also reacted, right? And on the other side, how many moles of HI must have been produced? 2x, right? I think it's 1:1:2, right? So double the amount of, so what you're going to get is 2x moles getting produced on the other side. So 2x moles are getting produced on the other side. So what are your equilibrium moles now, TK, based on this, or what you just did in terms of X? So your equilibrium moles will be, well, you started off with 0.2 moles and now you've X moles have reacted. So how many moles are you left with? You're left with 0.2 minus X. ये clear है? कि X moles चले गए? So is this
जी सर
the same thing over here? You started off with 0.2, X moles have reacted, so you're left with 0.2 minus X. And over here, you started off with 0.4 moles and there's a further 2x moles getting produced. So that means now you already had 0.4. Now there's an extra 2x moles getting produced. So you clear? So I've found my equilibrium moles in terms of X. Is that clear?
जी सर
Yes, sir.
And what's my Kc expression? My Kc expression is for this reaction is it's the concentration of HI squared divided by the concentration of H2 and the concentration of I2. HI squared होना है, ठीक है? This will be squared. ठीक है, that's my Kc expression. Achha, should I use concentration or can I use moles directly in this expression? But do I need to calculate concentration or do I just use moles directly?
I think
सर
you
ये
need to, sir.
No, I told you when you have equal moles on both sides, you don't have to find concentration. Is that clear?
Okay.
If you divide by volume on a partner, that gets cancelled out. So you don't really have to do that. Achha, but anyways, so you can just put in moles directly, plug in. We know the value of Kc. So what's the value of Kc? It's already given. That's 3.1. So you just have to solve this. So HI squared is going to be 0.4 plus 2x. And that's squared. And the whole thing gets divided by what? It's 0.2 minus x into 0.2 minus x. So that's 0.2 minus x into 0.2 minus x. So that's squared as well. So that's my Kc expression. I need to solve this. And that's a quadratic equation. They've specifically asked you not to solve quadratic equations. So without I mean, the whole minus p plus minus p square minus 4ac thing, they actually expect you not to use that. I mean, you can obviously solve it any ways you like. But the way that they want is that you take the under root on both sides. You're going to take the under root of the whole thing on both sides. And that way you don't really have to solve a quadratic equation. So it's going to be 3.1 under root, and 3.1 under root gives you two values. It's going to be plus 3.1 under root, or it's going to be minus 3.1 under root. So it's going to be 3 plus minus 3.1 under root. And on this side, it's going to be 0.4 plus 2x. And the bottom is going to be 0.2 minus x. Now we're going to solve it twice. One with plus 3.1 under root and the other one. So I'm going to get two values because it's a quadratic equation. So I'm going to solve it twice. The first time I'm going to solve it with plus 3.1 under root. So that's going to give me what? It's going to give me 0.2 times 3.1 under root. And minus x goes over there. So it's minus x times 3.1 under root. And on the other side, I've got 0.4 plus 2x. You have to be very careful with this. I mean, there's a lot of chances of making silly mistakes. So I get 0.4 plus 2x. I put the x's together, so it's going to be 0.2 times 3.1 under root and minus 0.4 ठीक है, bring the minus 0.4 to this side. Take the x on the other side, so it's going to be 2 plus 3.1 under root. And that's going to be your x. And you can just get rid of this from that side and divide it over here. So that will become 2 plus 3.1 under root. And this is what you have to solve. Can you try and solve this? What do you get? Make sure you use brackets in your calculator. Be very careful when you're like put this in a bracket. Then this whole thing is in a bracket. Divided by this thing. So what do you get for the first value of x?
minus 0.012.
If the x is minus 0.012.
0.012.
So 0.012, okay. That's one value of x. The other one I'm going to solve is for. Check karo, sorry, if everyone is getting this. The other one is I'm going to use minus 3.1 under root. The only difference would be I just take the same expression. ठीक है, तो उसमें कोई नई working नहीं करनी. All you have to do is take the same expression, copy it, or copy करने के बाद ना just change the 3.1 under root to minus 3.1 under root. So everything kind of remains literally the same. इसको हटा दो. So kind of the same thing. But यहाँ पे ना I'm just going to put a minus sign, minus 3.1 under root. So this thing would actually, this would be 2 plus, this will become 2 minus 3.1 under root. That's one difference. And this thing over here will become, ये क्या बन जाएगा? That's, instead of 0.2 into 3.1 under root, it's going to become minus. There's going to be a minus sign over here. ठीक है, is that clear? Okay. Don't waste time doing this all over again. Just take the same expression. Just change 3.1 under root to minus 3.1 under root. That's it. तो अब क्या आ रहा है? What are you getting for x?
Minus 3.14.
So this one is minus x. The second value of x is minus 3.14. So Bakio, is this Ahmed, Rafi, Hunaid, did you get the same value?
It's the same, sir.
Sir, for the first one, I got minus 0.013.
2 के आगे क्या था?
7.
7 आ रहा है.
हाँ, so वो 3 है, ठीक है. So this one will be, this one will actually round off to 3. And this is fine, right? Minus 3.14. Anyways, you're gonna get two values, right? But only one of them is correct. Because your table and the table that you drew earlier, okay, you're going to substitute these values of x in this table. So you're going to get two different sets of values for your equilibrium moles. Obviously, rule the moles can never be negative. Like when you're counting things, it can never be negative. Like if you've got a basket full of apples, you don't have minus 2 apples. Minus 2 can be a difference, but you don't actually have minus 2. I don't have minus 2 cars. You never have moles in negative. Is that clear? So now which of the values will give you a negative answer? I think ये जो 3.14 and minus 3.14. Like if I substitute minus 3.14 over here, so जो HI के moles है ना, that's going to come out to be negative moles. You can't really have negative moles. Okay. So that's why I'm going to reject this value. I said, remember the value can be x की जो value है, that could be any value. It can be positive, it could be negative. You're going to reject the value based on the equilibrium moles. The equilibrium moles cannot be negative. I'm going to write it over here. कि your equilibrium moles can simply not be. So when you substitute x, तो उसके लिए याद रखना कि equilibrium moles can never be negative. I said they cannot be negative, which is why I'm going to cross out this value. The value that's going to get I mean that's wrong. Why? Because I mean it gives moles in negative values. So वो फिर दूसरी value substitute the other value. So if we substitute the other value, इसको थोड़ा नीचे ले जाए. So I'm going to substitute this one. ऐसे हमारा केसी सॉल्व हो गया. अब यहाँ पे -0.013 यहाँ पे substitute this. So -0.013. How many moles do you get over here? क्या होगा -0.013? -0.013, right? So it's going to be what?
0.213.
0.213, right?
Mm-hmm.
So you're getting 0.213. And this will be the same, right? 0.213. What about the other side? -0.013. What do you get over here? And remember, it's minus. So 0.4 minus 2 times 0.013.
Uh, 0.374.
So we're getting 0.374 moles for this. So that's the whole question. You've been able to find out. You've been able to find by if given the value of Kc and the initial moles, you had no idea what the equilibrium moles were, right? So based on this, you were able to find out the equilibrium concentration. What you did was that you wrote down the initial moles. You made the table just like before. Everything was exactly the same. The only thing was you had no idea what your equilibrium moles were. So you made some assumptions. You assumed that you added 0.2 moles. So let's say X moles have reacted, right? So X moles have reacted. So that means the moles at equilibrium will be less than 0.2. It's going to be 0.2 minus X, right? X moles of this react, X moles of this will also react. It's 1:1. So this will be also 0.2 minus X. And if X moles react on the other side, double the amount will get produced. So that's 2X moles getting produced. And that will become 0.4 plus 2X. You already had 0.4. Now you've got 0.4 plus 2X. You found the moles, but in terms of X. You wrote down the Kc expression, but in terms of X. You knew the Kc value. So all you did was you just solved for X, and you're going to get two values. Every time you're going to get two values. One of them is going to be correct. The other one is going to be incorrect. How do you figure out which one is incorrect? You substitute the values of X that you're getting. And the one that gives you negative equilibrium moles, that's the one that's negative, TK. That's the one that's wrong. And you're going to cross it out. The value of X itself can be any number. It doesn't really matter. As long as you substitute its value and you don't get a negative number over here, then the value is fine. Okay, so this is your moles. They have to be a positive number. They can't be negative. Okay, so is this question clear? This entire question?
Ji sir.
Yes.
So all we have to do is, that's all questions would be exactly the same. The equations for this question are not going to be that complicated. It's always going to be a quadratic equation that you're supposed to solve. And you don't even have to solve the quadratic equation using the formula. All you have to do is take the under root. Beware of the fact that it's going to give you two values. It's going to give you a positive number and it's going to give you a negative number. You can try one. The other expression would be exactly the same. Just substitute the negative value over there. So the sign would change. That's about it. So I'll just start doing questions related to this. इस way से save कर लेते हैं. I said related to Kc. One second, do we have? That's this one. So again, we were doing questions. So I'm going to do एक second. ये तो पुराने थे. So we did some of these questions. The ones that we did not do. TK, we even did this one. I just saw इसके अंदर ना actually solve हुए हैं. Let me open the other one, unsolved one. This one. बल्कि उसी के अंदर ना जो solve नहीं हुए वो कर लेते हैं. Okay, it's this one. So they're saying that, let's do this question. They're saying that, write the expression for Kc. So it's product concentration over reactant concentration. So it's going to be HI squared. And the whole thing gets divided by the concentration of H2 and the concentration of I2. The units are no units, dimensionless. Concentration squared divided by concentration into concentration, everything is going to get cancelled out. Then he's saying for this equilibrium, the molecular value for Kc is 140 at 500 kelvins and 59 at 650 kelvins. Use the information state and explain the effect of the following on the equilibrium position. If you increase the pressure applied, what happens? The less gas moles side is going to be favored. So, I mean, we obviously know that. And there is no, in this reaction, there is no less gas mole side. Both sides, you got 2 moles of gas. So that means applying pressure will obviously have no effect. So in this case, no effect on equilibrium position. So there's not going to be any effect on equilibrium position. Why? Because you got equal moles of gas on both sides. As anyways, that's still not related to Kc. The other part is still decreasing the temperature of the equilibrium. When he increases the temperature, this one is interesting because Kc is 140 at 500 kelvins and 59 at 650 kelvins. So at a lower temperature, you got a lower temperature and the Kc value is 140. So Kc is higher, right? And then you've got a higher temperature and the value of Kc is lower. So Kc is smaller. Now, can you tell me what's happening here? If Kc is higher, do you have more products or do you have more reactants? But higher Kc kab hota hai? Do you have more products or more reactants?
More products.
And final में ये पहले initial में.
नहीं, initially बस वो Kc दिया हुआ है. It's already at equilibrium. So Kc value is higher. That means you got more products, right?
Yes.
जी sir.
So you got more products. It's favoring the products, right? And when the temperature was higher, the Kc was smaller. That means remember Kc value only gets affected by temperature. So higher temperature, but you had a smaller value of Kc. That means it's going to have more reactants. Okay? It's going to have more reactants. So I mean, basically Kc was what was Kc? Product concentration divided by the reactant concentration. So a higher value means more products. A smaller value means less products and more reactants, right? So what do you think? Decreasing the temperature, you're decreasing the temperature. From higher temperature, you're actually moving to a lower temperature. So where is the equilibrium shifting? From more reactants, it's shifting to more products, right? Is that clear?
Ji sir.
Yes.
So that means equilibrium will shift to the right side. It will favor the products. So the equilibrium will favor your products, and you'll have more products at equilibrium. Actually, they can also ask you, is this is the forward? I mean, you're going to have more forward reaction. Is the forward reaction endothermic or exothermic?
Exothermic.
क्योंकि जब आप temperature decrease करते हो, which reaction gets favored? It's the exothermic reaction, right? So that means the forward must be the exothermic reaction. Because you're decreasing temperature and a particular reaction is getting favored. Whenever you decrease temperature, the exothermic reaction gets favored. Is that clear?
Ji sir.
Yes.
ठीक है, बाकियों Ahmed, Abdullah, Unai, this is clear.
Yes.
Yes, sir.
So now coming back to the main question, which is about this thing. The addition moles are given. You know the value of Kc at 650. He's talking about 650 kelvins. We already know the value. The pisle part mein they gave us 650 kelvins. Its value is 59. So I know that Kc has Kc over here at this temperature has a value of 59. That's given in the last part. So how much of H2 is reacting? These are the initial moles. How much of H2 is reacting? I have no idea. So I'm going to write X moles react. So अगर यहाँ पे X react करें तो X would of I2 would also react. It's 1:1. So that's X reacting. And if X reacts with X on the other side, it's going to be 2X getting produced. Right? So your equilibrium moles will be 0.02 minus X. This would also be 0.02 minus X. Or जो HI के moles थे वो तो थे ही नहीं. You had 0 moles. Now you've got 2X getting produced. So you got 2X moles, right? So is that clear?
Ji sir.
Yes, sir.
So you got 2X moles. Now you just have to find, they already know the value of Kc. Kc is, as I remember, do you use moles, do you use concentration or do you use moles directly?
Moles, sir, moles.
Okay. Although you can find concentration as well. They gave us the volume as well. 1 dm cube, but it was kind of pointless. Like dividing by 1 dm cube would be kind of the same thing. Like, you can also use moles directly because the volume part will get cancelled out anyways. So it's going to be HI squared and divide by H2 and I2. So क्या करना है? It's going to be 2x squared divided by 0.02 minus x and 0.02 minus x, or you can say 0.02 minus x squared. Or value क्या? That's 59. I'm going to take the under root. The under root will be, so it's going to be 2x divided by 0.02 minus x and 59 under root. Then I would have to solve it. It's going to be plus 59 under root and it's going to be minus 59 under root. Then I would have to solve this. So क्या बनेगा? It's going to be 2x is equal to 0.02 plus के साथ times 59 under root. ये कोई मेरे से पहले solve करे. Minus x times 59 under root. Get the x on one side, so it's going to be 2 plus 59 under root. And 0.02 multiplied by 59 under root. और उसको फिर डिवाइड कर दो. So it's going to be divided by 2 plus 59 under root. Now remember, that's the first value, x1. The second value would be exactly the same, but with minus 59 under root. So it's going to be your top hoga, that will become minus 0.02 times 59 under root. Or Asaf, bottom pe it's going to be 2 minus 59 under root. So is this clear? These दोनों चीजें clear? Tell me the value. What do you get for this?
सर पॉजिटिव के लिए 0.16 है और नेगेटिव के लिए 0.27.
So you're getting 0.16, both positive values, right? And
0.27.
0.27. So मुझे बताओ कि which value of x is suitable to be used to find the equilibrium moles? Like, should I use this one? Well, 0.27 use करोगे क्या आएगा यहाँ पे? You'll get negative moles, right? अच्छा, apparently दूसरी भी use करोगे, you'll get negative moles. That means somebody made a mistake. इधर दोबारा करोगे इसमें. What did we make any mistake?
Sir, I think for the 0.161, it's 0.016.
ठीक है, this one is 0.016, I think. अच्छा, so one of them is 0.016, and you got 0.27. So we're going to use this one, right?
It's 0.027.
ये भी 0.027 है. ठीक है.
Yes, sir. Yes,
जी
sir.
सर.
0.027.
So I'm just going to add 0.0 as 0.027. Anyways, that will still give you negative moles, right? So I think you have to substitute 0.016. 0.016. If you substitute 0.016, what do you get? .004?
Yes, sir. Yes.
जी सर.
So you're getting positive moles. This is also going to be 0.004 moles, right? And this will be 2 times, so it's going to be 0.032 moles, right?
जी सर.
So all moles you got were, so this is the value that you're going to, this is the correct one, right? This one. And that's the incorrect one, because that's going to give the moles in negative. So question में ये था, calculate the amount in moles of each substance present at equilibrium. You were able to do that. ठीक है, is this clear?
जी सर.
Yes.
अच्छा, और so most questions, ठीक है, सारों को clear है. Most questions are going to be kind of similar. Let's do another one के ये वैसे ही कर लेते हैं. Explain what is meant by a strong acid. It ionizes fully. In aqueous solution and is a proton donor. ठीक है. So in aqueous solution, और acid की अपनी definition है कि it is a proton donor. Complete the equation. HI is ionizing, so it's going to produce H plus 1. Or second, behaves as a strong acid. Sorry, it behaves as a strong acid. So what will it do? It's going to release an H plus 1. So what will happen is that the HI will only I minus 1 will be left, because it's behaving as a strong acid. So who's going to accept that H plus 1? Water is going to accept that H plus 1. and it will become H3O plus 1. Remember about water ke water jo hota hai na, it's got lone pairs that are capable. These lone pairs, it's got electrons that are capable of forming dative bonds with H plus 1. वो H plus 1 को ना attract कर लेते हैं, so it becomes H3O plus 1. But the simple thing was that he was saying that it behaves as a strong acid. So that means it is going to release an H plus 1 and the water has to accept that H plus 1, ठीक है, because it is behaving as a strong acid in water. तो ये अपना H plus 1 देगा और water gain कर लेगा. Water will become H3O plus 1, ठीक है. Even without knowing this fact, you should know this would be your equation. Is that clear?
जी सर.
अच्छा,
Yes.
अच्छा, so you conjugate base वाला part तो हमने किया ही नहीं है, तो I'll just ignore that for now. This next question, ये तो है easy है. So try, nee, this is also easy. One second. Achha, try finding this question. I'm sending this question. This is your homework, okay? So try and figure out what's going to happen here, okay? मैं WhatsApp, I'm sending it on WhatsApp. तो ये करके मुझे solve करके भेज देना, ठीक है?
ओके सर. सर वो रिकॉर्डिंग भी भेज दें.
वो मैं ऐड करूँ, मैं उसका लिंक भेज दूँ, ठीक है? चले, okay.
अल्लाह हाफिज़.
Okay, thank you, sir.